overloading and overriding. Introduction. A definition of overloading.
We use the term overloaded if it has two or more meanings.
Most words in natural languages are overloaded, and ambiguity is resolved by means of context. Same is the case of object-oriented languages. Overloaded names can be resolved by two important classes of context. Overloading based on scopes. Overloading based on type signatures. Overloading based on scopes. A term scope defines the portion of a program in which a name can be used or the way it can be used. Scope are introduced using lot of different mechanisms. Classes are interfaces. Packages are units. Procedures are functions. In some languages, it is called even blocks. An advantage of scope is that the same name can appear in two or more scope with no ambiguity. Florist example. The above diagram explains about the overloading concept, and sendFlowers2 method is overloaded between the two classes. Resolving overloaded names. By looking at the type of the receiver, this type of overloading is resolved. Allows the same name to be used in unrelated classes. Since names need not be distinct, they are allowed to be short, easy to remember, and meaningful too. Overloading based on type signatures. A different type of overloading allows multiple implementations in the same scope to be resolved using type signatures. The below given example different overloaded methods. The sum is the method overloaded in the class example. The first method pass one argument, the second method pass two arguments, and likewise third method pass three arguments.
A combination of argument type and return type is called a type signature. By looking at the signature of a call, one can tell which version is intended.
Resolution performed at compile time. Note that resolution is almost always performed at compile time based on static types and not dynamic values. Class A, open bracket, public void m of integer I, open bracket, system.out.println integer, bracket closed. Public void m of string s, this is an overloading method, system.out.println string, bracket close. Class B extends A, public void m of integer I, open bracket, this is overriding method, system.out.println overridden integer, bracket close. Class example, open bracket, public static void main string arguments, open bracket, A, object A equal to new A of A dot M of 1, A dot M of ABC, A, object B equal to new B of B dot M of 1, 2, 3, 4, bracket close. The above given example shows the compile time polymorphism. There are two classes, one is class B and another one is class E. Class B is the child class and class E is the parent class. These two classes overload the method m with different arguments. In the class example, the two objects are created. One is for parent class and another one is for child class. The respective methods can be called based on the object.
The output is shown here.
Substitution as conversion. Resolving overloaded function or method calls can get very complex when one adds conversions into the mix. There are many types of conversions. Implicit value changing conversion, such as integer to real. Implicit conversion that does not change value, pointer to child class converted into pointer to parent. Explicit conversions, cast. Conversion operators, C++ and the like. Redefinition. A redefinition occurs when the type signature of a method in the parent class is changed by the child class. Two different types of rules are used to resolve names. The merge model. The scope of the child is merged with the scope of the parent. The hierarchical model. Scopes are separate. Search is made for first scope containing name and then for best fit within the scope. Example illustrating redefinition models. The following example will highlight the differences in these two models. The below given example explains about the overloading concept and it executes the parent method. First it will print the parent method and then it will print the child class method. It will execute the parent method in Java and C# in merge model and give error in C++ in hierarchical model. Delphi allows programmer control over this. Optional parameters. Some languages allow the programmer to create optional parameters, usually only at the end of the parameter list. Class rectangle, open bracket, public void, area rect of integer length, integer breadth, integer height equal to 1, open bracket, integer area equal to length into breadth into height, system.out.println. The area of the rectangle is plus area, bracket closed. Public static void main string arguments of open bracket rectangle r equal to new rectangle of r dot area rect of 5, 6 bracket closed. Such a program will have more than one type signature. In the above class, rectangle area rect is the method defined. This method has two required parameter and one optional parameter. The object has been created for the rectangle class and it called the area rect method by passing two values. After passing the required values, the area has been calculated and it will be printed.
The output is shown here.
Summary. Chapter Summary. In this chapter, we have looked at various aspects of overloading. Overloading based on scope. Overloading based on type signature. Redefinition. Polyadicity. Functions with variable number of arguments. Overriding. If two methods have the same name and type signature, method in a child class overrides a method in a parent class. Like overloading, there are two distinct methods with the same name. The following are the differences. Overriding only occurs in the context of the parent-child relationship.
Using the type signature.
Sometimes overridden methods are combined together.
Overriding is done at runtime, not at compile time.
Notating overriding. When a method with the same name and type signature is redefined by a child class, naturally it comes as an output of overriding, particularly in some languages such as Smalltalk and Java. Overriding occurs only if the parent class has declared the method in some special way. Example, keyword virtual. In languages like C++. Overriding takes place if the child class declares the method in some special way. Example, keyword override in some languages, especially in Object Pascal. In some languages such as C# and Delphi, overriding occurs if both parent and child class declare the method in some special way. In the below given program, the method is declared as virtual in the parent class and override method is declared in the child class with the same type signature. Class parent, open bracket, public virtual integer example of integer a, bracket closed. Class child parent, public override integer example of integer a, bracket closed.
Replacement and refinement. Two different ways to handle overriding. The code in the parent class is replaced by the code in the child class with the help of replacement. A refinement manipulates the code in the parent class and adds it to the code in the child class. Almost all the languages use both types of semantics in different situations. For example, constructors frequently use refinement. Reasons to use replacement. Below given are the reasons for replacement of methods. The method in the parent class is abstract and it must be replaced. The method in the parent class is a default method, so it is not appropriate for all situations. The method in the parent class can be more efficiently executed in the child class. Overriding a default method. The list shown is an example of overriding a default method in Smalltalk. Class number incubes child classes integer, fraction, and float. Method in class number is defined as follows. Class number square root, self as float square root. The method in class float out to perform something different. Here it is computing the square root. The parent class method works a lot than the child classes. Overriding for optimization. The following given example can show how a child class can do the same action more efficiently and effectively than the parent class. Class Boolean has child classes true and false. Class Boolean ampersand right, self if true colon right if true true, false right, self if true true, right if true true, false. These general algorithms do work for either true or false values. More efficient versions in class true. In class true, we can be very clear that the left argument is true, hence it can make more efficient algorithms. Class true, ampersand right right, right true. The same efficient code can be in class false. Though these are faster than the code in the parent class, they have the same effect. Downside of replacement. The downside of replacement semantics is that there is no assurance that the child class has no meaning equal to the parent class. For example, a child class could reframe square root to compute the cube root of its argument. This leads to the difference between subclasses and subtype. A reframing is more difficult since whatever the parent does is inherited to be the part of the child. This is the reason for most languages use refined semantics for constructors. Refinement in beta. Beta is interesting that it always uses refinement. The parent method is always executed first if it executes the special inner statement. Meanwhile, the child method is also executed. The child class can in turn do an inner and so on arbitrarily. If a class has no child, the inner statement has no effect at all. Simulating refinement with replacement. Despite language usage replacement, the most important features of a refinement can be simulated. Class parent open bracket void example of integer a open bracket system.out.println in parent bracket closed. Class child extends parent open bracket void example of integer a super.example of 12. Here super refers to parent class. System.out.println in child bracket closed. The above given program shows the example method is overridden. Super keyword is used to call the parent class method. Note that this is not quite the same as beta, as here the child wraps around the parent, while in beta the parent wraps around the child. Constructors use refinement. Most languages have constructors which will always use refinement. This assures that whatever initialization the parent class performs will always be updated and accepted as part of the initialization in the child class. Overriding versus shadowing. In programming languages, it is not uncommon for one declaration of a variable to shadow a previous variable of the same name. In the below given program, the x is the instance variable declared as private, and in the example method, another x variable is declared as argument and it shadows the instance variable x which is declared already as private. One can resolve shadowing at compile time. It does not demand any runtime search. Shadowing of instance variables in Java. Java allows instance variables to be redefined and uses shadowing. In the below given program, the variable x is used both parent class and child class. The respective variable can be called using respective object. That is, if you want to print parent class variable, we have to use parent class object. Likewise, if you want to print the child class object, so we need to use the child class object. Shadowing methods. Most languages require the virtual keyword in the parent class. If it is omitted, it will use shadowing. The below example shown the shadowing the methods which is declared in both parent class and child class. Methods can be called through parent class and child class object. Deferred methods. If in the parent class, when the method is defined but not implemented, we can say that the method is deferred. They are sometimes called abstract methods and in C++ otherwise pure virtual method. Overriding, shadowing and redefinition. Overriding. Both parent and child classes have the same type of signatures and the method is called as virtual in the parent class. Shadowing. The type signatures are the same in parent as well as child classes, but the method is not declared as virtual in the parent class. Redefinition. The type signature of the child class differs from the parent class. Covariance and contravariance. When a method is overridden, we could alter the argument types or return types. Covariant means making a change down the inheritance hierarchy and making it more specific, whereas change that moves up the inheritance hierarchy is said to be contravariant. The below example shows the contravariants used in the classes. Summary. Chapter Summary. An override occurs when a method in the child classes uses the same name and type signature as a method in the parent class. Unlike overloading, overriding is resolved at runtime. There are two possible means for an overriding: replacement and refinement. A name can shadow another name. Some languages permit both shadowing and overriding. Shadowing is resolved at compile time. A change in the type signature can be covariant or contravariant if it moves down or up the type hierarchy. The semantics of both types of change can be subtle.